Hello there. In this video, we'll be learning about infinite limits. To start, as a motivation, we consider the function 1 over x. Observe that at x equals 0, this function is undefined. So clearly, if we take its limit, the limit does not exist. But what if we still want to know the behavior of the graph at this point? Well, let's try to analyze its values from the right and the left, starting with the right. So we'll have this table out here. So we have here the values of x close to 0 from the right, and let's try to find the value of f of x. So at x equals 1, so we just plug this in. So we'll have 1. At x equals 0.1, we'll have 1 over 0.1, and then just move this decimal points out here to get 10. We do the same for the remaining values to obtain 100, 1000, 10,000. Now let's try to inspect the values close to x equals 0, but from the left. So these are negative values. And let's try to find f of x. So at x equals -1, we'll have 1 over -1. So this is just -1. At -0.1, we'll have -0.1. Move this decimal places out here and we'll get -10. We do the same again for the remaining. So we'll have these. So what can we observe? Observe that as x gets closer and closer to 0 from the right side or from positive values, f of x increases, constantly increases. Similarly, as x approaches 0 from the left or from negative values from the left of 0, the value of f of x constantly decreases. And these two are without bound, since f of x increases without bound and f of x out here also decreases without bound. And indeed, if we check out its graph, so let's try to plot it in here. So we have this graph of f of x. So again, f of x is 1 over x. Observe that at these values, at values approaching 0 from the right, so this is x equals 0 out here. It approaches this one, constantly approaches or increases without bound, which means that it goes to infinity. So we say that the limit as x approaches 0 from the right of f of x is equal to positive infinity. And similarly, for values out here, so as x approaches 0 from the left, the value of f of x constantly decreases without bound, or it approaches negative infinity. So we say that the limit of f of x as x approaches 0 from the left is equal to negative infinity. And so these two are what we consider infinite limits. So as you can see, even though the limit clearly does not exist, since it doesn't approach a finite real value, and moreover, it is not equal, since out here we have positive infinity and negative infinity. It's still nice to learn about this, since we'll be able to have a better understanding on the behavior of a function, in this case the function f of x equals 1 over x as it approaches 0. So yeah, with that out of the way, let's try to define infinite limits, though not formally, but to have a better understanding of it. So let's have infinite limits. So as we have seen earlier, we had the limit of f of x as x approaches a is equal to positive infinity. When we see this, this refers to the function f of x increasing without bound as x approaches a. Or this happens when we have c over 0, when we see that the limit approaches c over 0 upon plugging in a. But take note that c out here must be positive. So whenever we see this, we can conclude that the limit approaches positive infinity. Aside from this, we also have the limit of f of x as x approaches a equals negative infinity. What this means is that f of x decreases without bound, and this happens when we have negative c over 0, when our limit approaches this value as we plug in x equals a, x as we plug in a out here. Take note again that c out here must be positive. So these are what we need to take note in infinite limits. And aside from this, we also take note that in here we can actually replace this with its one-sided limit version. So we can consider the values from the left and from the right, as we have seen in our previous illustration. Moreover, as noted earlier, infinity is not a real number. So even though we have the limit to be equal to this means still that the limit does not exist. So take note of these two out here. Now, before we try out some examples, we'll define another thing related to this, and that is the vertical asymptote. So let's try to define this one. So let's start with asymptote. So when we say asymptote, this refers to a line that approaches a curve but never meets it. So approaches but never meets. So it's like, they say that this is a sad story in math, since it's like getting closer and closer but never intersecting or never meeting it. So it's like, let's have an illustration. So let's consider this, see this curve out here, and then consider this, there. Let's try to consider this line. There. So in here, observe that this curve constantly gets closer and closer to this line out here, but it never meets it, since we denote this to be broken lines. And when we refer to broken lines, this means that this curve doesn't meet it. So something like that. So I hope that that one is understandable, but let's try to define this further. Aside from the asymptote, let's define vertical. When we say vertical, we refer to graphs of x equals a. Since we know that if we have x equals a out here, its graph is given by, so if this is a, then its graph is given by this. So it is a vertical line. Now, the important thing to relate vertical asymptotes and infinite limits is that the requirement here is that x equals a, wherein the one-sided limit of the function f of x, or the curve, is equal to positive or negative infinity. So either of these two. So in our example earlier, so let's try to put that one out here. So we have f of x, and again f of x out here is equal to 1 over x. We know here that the limit as x approaches 0 from the right of f of x is positive infinity, and from the left is negative infinity. So this one out here satisfies the condition for our vertical asymptote. So we can conclude here that the graph x equals 0 is a vertical asymptote for this function. So the vertical asymptote of f of x equals 1 over x is x equals 0. So take note of this one. Now we are ready to try out our examples. So starting with the first example. So in here we are given if f of x is equal to 1 over x squared, we're tasked to find the limit of f of x as x approaches 0 and its vertical asymptote. So before we try out this one, feel free to pause the video so that you may try this one first on your own. Okay, so let us start. So to solve this, let's try to inspect the limit of f of x as x approaches 0 from the left and the right. So let's have the limit as x approaches 0 from the left first of f of x, which is 1 over x. So let's try to inspect that. So if you plug in 0 from the left, we'll have 0 from the left. And take note that the values from the left of 0, these are values like negative 0.0001. So if we square this one, we'll have a positive value. That is still close to 0. So this will be equal to 1 over 0 with a positive out here to denote values from the right of 0. So clearly, since these two are positive, and we are of the form constant over 0, wherein this is positive, so we say that this approaches positive infinity. So the limit for this one is equal to positive infinity. Sorry about the noise. I don't know if it can be heard. Let's try to check the limit as x approaches 0 from the right of 1 over x. So let's try to inspect this one again. So we'll have 1 over 0 from the right square. So we know that the values from the right of 0 are 0.001. If we square it, it is still positive, or 0. Or what I mean by that is that it is still close to 0, but positive values close to 0. So this one out here will still be equal to 1 over 0 with a positive sign. So we know that similar to the first one, this approaches positive infinity. And so we conclude that the limit for this one is equal to positive infinity. Since these two are equal, we conclude that the limit as x approaches 0 for f of x is equal to positive infinity. So we have acquired the answer for this one. Just take note that, again, even though the limit out here is equal to positive infinity, this still means that the limit does not exist, as we had remarked a while ago. Next, we try to find its vertical asymptote. And since, observe here that the one-sided limit is equal to positive infinity, so we can conclude that this one out here, with the help of this one, we can conclude that the vertical asymptote for the function 1 over x squared is x equals 0. So that is the answer for this problem. And you may check out its graph if you want. It would look something like this. So I think it would look something like this, wherein this refers to f of x equals 1 over x squared. There. So it's like our previous example a while ago, but this time it's both positive since we have square out here. So as you can see, the vertical asymptote out here is at x equals 0. And the limit from the left and the right approaches positive infinity. So that is the answer for this first example. I hope you got that one correctly. And now let's move on to the second example. So we are given here g of x equals x minus 1 over x plus 2, and we are tasked to find the limit of g of x as x approaches negative 2 and its vertical asymptote. So again, feel free to pause the video so that you may try this one first on your own. Okay, so let's start. So again, let's try to inspect the limit from the left and the right. So we have the limit as x approaches negative 2 from the left of g of x. So we have x minus 1 over x plus 2. So let's try to inspect this one. So plugging in negative values from the left of negative 2, we'll have 2 from the left minus 1 over 2 from the left plus 2. For the numerator, this will be equal to negative 3. So we won't have any problems there since these are just, what do you call this? This is just a fixed value. So we only have problems when we are at 0. So for the denominator, take note that negative 2 values from the left of negative 2 is equal to negative 2.0001, something like this. So when we add this 2, we'll have values close to 0 but is negative since this one is greater than this. So we'll have here 0 from the left. So since these two are negative, we can divide the negative signs out here to obtain 3 over 0 from the right, or positive values close to 0. This means that since we are of the form constant over 0, wherein we have a positive, let's move this one first, this approaches positive infinity. And so we say that the limit from the left out here is equal to positive infinity. Good, so let's go on to the limit as x approaches negative 2 from the right. Oops, this should be minus 1. X plus 2. There. So let's try to inspect it as well. So we'll have here negative 2 from the right minus 1 over negative 2 from the right plus 2. So for the numerator, again, we won't have any problems. For the denominator, take note that values from the right of negative 2, those are negative 1.9999 and so on. So when we add 2 out here, the outcome is close to 0 but positive. So we'll have here 0 from the right. And since we have negative value out here and positive out here, so this approaches negative infinity. So the limit for this one is equal to negative infinity. And so, since these two limits are not equal, we say that the limit indeed does not exist. That's right, g of x does not exist. Well, in the first place, we already know that it does not exist. But now we know that it is not only does not exist, but also the limit out here is not equal. So there's nothing special with it, like having a positive infinity or a negative infinity. So I hope that's clear. For the vertical asymptote out here, since again the one-sided limits out here is equal to positive negative infinity, with the help of these, we can conclude that the vertical asymptote for g of x is x equals negative 2. So these two out here are our answers for this problem. So I hope you got that one correctly. And now let's move on to the last example. So in here we are tasked to find the vertical asymptote or asymptotes of h of x equals x over x squared minus 1. So again, feel free to pause the video so that you may try this one first on your own. Okay, so let's start. So in here, we don't have any limits to find out here. So unlike in the first examples, we had an idea on what the vertical asymptote would be. But how about in this one? We'll take note that the technique is to equate this denominator to 0. So we'll do that one. So we'll have here x squared minus 1 equals 0. This will become x squared equals 1, get the square root both sides, and we get x equals positive negative 1. So the vertical asymptotes are x equals positive negative 1. As simple as that. But since we are studying limits out here, or infinite limits to be exact, let's try to indeed show that this is true. So let's try to inspect the limit as x approaches, say 1 first. 1, and we can choose either the left or the right, since it doesn't really matter. So let's try to check from the left of h of x. So we have x over x squared. X over x squared. Wait, let's try to fix this one out here. So right here, vertical asymptote squared x equals positive negative 1, and we check the limit as x approaches 1 from the left of h of x. Take note that it doesn't really matter if we choose from the left or the right, since the important thing out here is just to show that the limit from either side is equal to positive or negative infinity. So to solve this, first, take note that x squared minus 1 out here is equal to x minus 1 times x plus 1 by difference of two squares, factoring method. So we have here the limit as x approaches 1 from the left of x over x minus 1 times x plus 1. And in here, let's try to inspect. So from the left of 1, we'll have here 1 from the left, 1 minus, wait, let's just put it in here. So we have 1 from the left over 1 from the left minus 1, 1 plus 1. There. So in the numerator, we won't have any problems. For this one out here, we won't have any problems as well. But for this one, take note that values from the left of 1 are like 0.999. So when we subtract 1 to that one, we'll get 0 from the left. Or we get values close to 0, but negative. There. So this one out here would become, so when we multiply the denominator, it would become that. And since it is of the form constant over 0, but this time it is negative, then this one out here approaches negative infinity. So we have here negative infinity. So indeed, x equals 1 is a vertical asymptote. Now for the next one, I will leave that one as an exercise. So this is an additional exercise. The goal is to show that x equals negative 1 is indeed a vertical asymptote. So to do this, you'll just need to show that the limit as x approaches -1 from the left or the right of h of x is equal to positive or negative infinity. So take note of this exercise. And aside from that, here's another exercise that you can work on. So we have here the limit as x approaches -2 from the right of x squared plus 2x plus 4 over 2 plus x cubed. So as a hint here, the technique is to split this up. Since take note that we can write this as the limit as x approaches -2 from the right of x squared plus 2x plus, so this one out here, plus the limit as x approaches -2 from the right of 4 over 2 plus x cubed. So this is just a property of limit that would be helpful in answering this problem. So just split it. So yeah, that's it. So that is the idea or the lesson on infinite limits. If you have any questions, feel free to comment it down on the comment section below, or if you have a solution and an answer to this problem, you can also comment it down below. Let's just clean this one up. So again, this is the exercise to try. So yeah, it's quite a long video since I really tried to put in various examples out here, and yeah, so that we could practice out the concept of infinite limits. In the next video, we'll probably be discussing the concept on the counterpart of infinite limits, and that is limits at infinity. So yeah, that's it. I hope you enjoyed this one, and that's all for this video.